let's have a look now at the graphs of the three fundamental trigonometric functions. And they are y equals sine of x, y equals cosine of x or cos of x, and y equals tan of x. Okay, and why it's called a function is because we could, in fact, represent this in a way that where sine can take in a value, and the value's an angle. Okay, and we're going to limit the angles between 0 and 360 degrees. I know that we can use angles that are bigger than 360, and we can use angles that are negative, but we're going to limit it to just angles between these two values there. And so for a given value of x, we'll get a value of y that corresponds to that after the sine operation is applied. Okay, and just to save a little bit of time here, so I'm going to use a little bit of technology here to graph this. Okay, so sorry and apologies for the reflection there. So might just zoom in on that. So this is sine of x, and so what we'll do is we'll analyze this in a little bit of detail. Okay, and there we go. Okay, hopefully we can see that okay. So this is on the Casio FX CP400 graphing calculator. Very handy little gadget actually. So if you sort of don't have access to the internet, or you just want something specific to do algebra or graphing and that kind of thing, this is a very useful device for that. So if you go backwards to sort of to negative angles, you can see that the graph of sine of x just keeps repeating itself, doesn't it? It almost looks like a heartbeat, doesn't it? A mathematical heartbeat. I like that. Okay, but we're going to limit our angles. So the angles here on the x-axis, just between 0 and 360 degrees. Okay, so I might be able to just zoom in on that a little bit. Hopefully that'll work. So just a little bit laggy. There you go. Yep. Okay, it just makes it a little bit clearer. Okay, so 0 to 360 degrees. What we can see here is that the sine curve goes up to 1. Okay, so the maximum y value is 1, and the minimum y value is -1. And notice that y equals 1 when sine is 90 degrees. In fact, there's a good reason for that. And if you think of all stations to central, think of angles of any magnitude. What happens when theta is 90 degrees, right? The line or the angle is basically lies on the y-axis and goes up to the top of the unit circle. Okay, we have 180 degrees. Okay, and y is 0 at 180 degrees. Okay, at 270 degrees, y is -1. And at 360 degrees, it's sort of like it ends one full cycle, and the cycle kind of starts again. And it just keeps repeating over and over and over. So you could go forever and ever. That's why we have to limit the angle between 0 and 360 degrees. So there we go. So I guess drawing that freehand, okay, so I'll just zoom back out again. Okay. Again, you can do this fairly quickly, okay? So if you have grid paper, it's obviously a bit easier, but if you have to draw that freehand, okay, that's x, or you could use, or theta if you like, whatever you like. There's our y value there, there's our origin, okay? And I'll just draw as smooth as possible, okay? There's our 360 degrees, okay? This is our 180 degree mark, okay? This is 270 degrees. And our peak occurs at 90 degrees there. Okay, the sine curve will dip down to -1, sort of at its minimum point there, and its maximum point there is +1. Okay, it's sort of got a nice sort of shape to that, sort of a curved shape to that. Now, one thing worth noting as well, that 0 to 90 degrees. Okay, I just really want to just point this out to you. This is quadrant 1. Okay, so if you think back now to the number plane, okay, and there's our positive x-axis and there's our positive y-axis there, there's our origin. Okay, so starting off in quadrant 1, remember all stations to central, all stations to central. Okay, so in quadrant 1, sine is positive. In quadrant 2, okay, sine is positive. It's above the x-axis. The graph is above the x-axis. Okay, so that's quadrant 2. Okay, and that's positive as well. All right, quadrant 3, only tan and cosine are positive, so sine is negative. Okay, so these are our 4 quadrants. Okay, so this is quadrant 3, and there's our quadrant 4. Quadrant 3 is negative, quadrant 4 is also negative, and it also corresponds to our angles of any magnitude. Okay, once the angle gets down to quadrant 3 and quadrant 4, which are these 2 quadrants here, the ratio is negative. What you'll notice as well, there's some symmetry. Okay, so take note of the symmetry. So in fact, if we go back from 90, say a certain amount, and go forward from 90 at a certain amount, you end up at the sort of the same y value as well. So I'm not going to spend too much time on the symmetries and looking at this into excessive detail, but just for the time being, what is important is that you know how to draw one of these. Okay, very simple, straightforward, from 0 to 360 degrees, getting the shape right, and also making sure that we go from starting from -1 to 1, the y values, and making sure that we get the correct, sort of, I guess, the correct horizontal sort of shift or the phase, and making sure that the curve is positive where it needs to be positive and negative where it needs to be negative as well. Okay, so that's the sine curve, a very simple sine curve. Oh, one last thing. Sorry, all these ideas keep flowing. At 90 degrees, okay, why is sine 1? I did ask that question earlier. So at 90 degrees, first to draw a unit circle, okay, just around there. Remember, a unit circle has a radius of 1. Okay, so if we start off with okay, so let's start off at 0 degrees, okay, and rotate 90 degrees, okay, and so this is going to go all the way around, yep, all the way around the circumference. It's going to go, I'm going to stop right there, okay, and if you remember the coordinates, okay, of any point on a unit circle, x is cos of theta, y is sine of theta. Now, at that point, the x is right on the y-axis at y equals 1. And that's theta is equal to 90 degrees at that point. Okay, so we've rotated 90 degrees, and that's why sine of 90 is in fact 1, because this point here, starting off on the positive x-axis, has travelled all the way around, walking, yep, keep walking, yep, oh, there you go, it stops right here at 1, y equals 1. Now, as it goes past sort of y equals 1 and keeps going now to quadrant 2, all the way to the end of quadrant 2, stops right there for a rest and has a bit of a break. What's happening there? That's 180 degrees. Sine of 180 degrees, well, that gives you sort of the distance away from the x-axis. It's on the x-axis. Therefore, it's 0. And that's why, that's part of the reason why, well, actually the reason why, the graph of sine is 0 at 180 degrees. Because as we're going around this circle, we're really only sort of interested in how far away from the x-axis we are. Okay? So the furthest away from the x-axis we can be, as we're going around and around this circle, the furthest away we can be is 1 unit away. Okay, so think of something that's just turning around and around, this little, like a fan blade, right? You go around and around and around. Up here, that's y equals 1. That's as far as it's going to get from the x-axis. And guess what happens at the other end? The furthest it can go away from the x-axis in the negative direction, have a guess, -1. And that's that point there. Okay, and that's the graph of y equals sine x. In the next video, we're going to have a look at the graph of cosine of x and look at the relationship between sine of x and cosine of x. And of course, you know that the cosine is just the complement of sine. You would expect the shape to be identical, but is it located in the same way? We'll see in the next video.